Sure.
Hello, Eric. Hi, how are you? Thank you so much for taking out time for our podcast. Let's talk about data. And how are you?
I'm doing great. Well, first off, Mustafa, thank you very much for having me on the podcast. I'm looking forward to exchanging some ideas, especially around data, but also hopefully around agents, which is kind of where my focus has been recently.
Yeah, awesome. I think this is our topic is agentic AI, and this is a buzzword buzzing everywhere nowadays. And there was a event couple of days back, 24 hours event. Not sure you have heard about it, the artificial unintelligence. So Eric Miller conducted this couple of days back. So
Uh,
I did some speaking on agentic AI as well. Tell me. Yeah.
yeah, I don't know specifically about that, but let me tell you one of the things that I see out there and why I'm so excited about this is.
I think let's
um,
let's start from basics. Tell us about yourself because my idea audience doesn't know about you. So
Yeah, sure.
we start with
I
introduction.
was gonna probably get into that eventually, but so my name's Eric Broda. I'm out of Toronto, Canada. I run a boutique consulting firm called Broda Group Software, and what we do is we help companies build ecosystems. Now, uh, what does that actually mean? We started the company about 10 years ago. Before that, I did my stint with the consulting companies. I was an executive, senior executive at a global bank, and then a senior executive in global chief architect at a large insurance company. But about 10 years ago, I started my company and like I said, we build ecosystems. It started with APIs back in the day and a service mesh. And then we went to data products and a data mesh. And I wrote my first book with O'Reilly on implementing data mesh. It came out October last year. And then what we've been focusing on the last almost 2 years is agents and the agentic mesh or the agent ecosystem. And that's the topic of my second book with O'Reilly. It's entitled Agentic Mesh, and it's all about the agent ecosystem. And the theme, if you will, is really around one core thing is we all hear what Andy Jassy, for example, the CEO of Amazon, said, where there's going to be billions of agents, and then Jensen Huang said there's going to be millions of agents in hundreds of millions of agents in every single company. And then Satya Nadella said, agents are going to replace software as a service. So the thing that gets me really excited is first off, even if they're way wrong, and it's not a billion agents in every company that Andy Jassy has, but maybe it's 1 millionth of that, and it's a million agents in every company. We're talking about a lot of agents running around. So our whole focus and what we do is we help companies accelerate their agentic or agent journey. And our specific focus is around enterprise grade agents and an enterprise grade agent ecosystem that they run in. After all, if you want to move out of the science experiment phase where people are experimenting but they can't get it into production, you have to think about enterprise grade capability. And if you're going to have 10, 100, or a million of these agents in your company, you actually have to think about the ecosystem that they run. And there's very few companies that actually manage 1,000, let alone 10,000 or a million of anything. So there's a different way of thinking, and that's what we do with our clients is we help them move from science experiment to enterprise grade agents to enterprise grade agent ecosystems. So that's a little bit about me and what we've been focused on.
No, actually, this is great. Actually, by the way, I've written a book on agentic AI as well. Uh, that research came last December. One of the
Mhm.
university research center published the paper. Then I had to, because I'm a data guy for last 20 years. And just a quick background because we are meeting first time. So I'm also in data for last 20 years. So I've
Mhm.
started with my career as a DBA, but most of the career I was ETL engineer. Uh, Now they call it data engineer, right? Then I jump into project management, become an architect. Now I'm leading a solution architect in a big company, oil and gas company. So suddenly last year I started this podcast. I was meeting with a lot of people like you since my first book like 5 years back. Then I ended up writing five books. So people started connecting, and we started having offline sessions for around 3 years. And then last year, we started recording this. When we started recording it, then you know better than me, right? You read a book, you hear a podcast, and you do a podcast like I'm doing with you one to one. It's a totally 100% 360-degree more
Hmm.
learning when you personally talk. So whenever new topic comes, normally I start writing about it. Actually, my first key book is called I Am Datapedia. So it has around 330 topics. So I keep adding 50 to 100 topics every year. So started with 70 topics. Now it is 330. In Jan, it will be 400, 450 topics. So now when this agentic AI comes in, then I jumped into it because I have to talk with people, right? And then I realized it's a huge thing. Then I have to create a prototype on my laptop. And then I realized, okay, I've done research. Why not write a book? So I end up writing a book, all my research paper, right? And when I was doing it, somebody named you.
Ah,
We talked
okay.
to Eric because he's doing good stuff on agentic. That's how I came to know about you,
Okay,
right?
fantastic, fantastic.
Yeah.
Well, whoever that was, thank you very much for the introduction. That's great.
Yeah. So in last 1 year, just to give you a background, why this podcast becomes so important for me and rest of the folks as well, because we started in June last year. This July, we came to know I end up interviewing people from 30 countries and around 60 odd data industry leaders. So it become a very senior and raw kind of podcast. And you will see, because I'm a solution architect, you will see the question I will throw onto it. And I will really try to understand how this agentic AI really works in your point of view, right? So I
Sure.
think let's jump into it, right? Uh, as I just mentioned, this artificial unintelligence event, I just gave a speech a couple of days back, presented a deck, in fact, where I do mention that, uh, first of all, the good news is jobs are not going anywhere. Jobs will still remain there. Agentic AI is not killing anyone. Maybe productivity will multiply by 10, but jobs will not reduce. That's my point of view. I will also ask questions on it. And then I also mentioned in my deck that there are around 14 to 15 type of agents. So you're absolutely right. There will be a lot of agents. So when you say millions and hundreds, that is where I will come to you that, okay, let me throw that question to you itself. If there are 14 to 15 type of agents, right? Because roles are only limited roles in an organization. Ultimately, you are going to replace or you are going to bring in more agents to work on the same role. It's not like that new roles will come. So why people are saying there are hundreds and thousands of agents? Are they saying, for example, if there are executor agents, there'll be 100 executor agents, but those are one type of agent. So how you differentiate it?
Yeah, so the simplest way to look at what an agent is to look at what a person is in an organization. So it's actually quite an appropriate analogy. It does break down a little bit, but let me explain the point a bit. When I look at an agent, I look at what a person is, and a person in a company has a particular role, and they obviously have skills to fulfill that role. With LLMs and the capability that we have now, we can have an agent that does the same thing. Now, whether they augment the person, replace the person, or they sit beside the person, is largely that's a discussion that we can have a
Yeah.
little bit later on in the podcast. But for the analogy that we have is an agent's like a person. And just like people can work together in a team, we can have agents work together in a team. We call them fleets of agents, just to differentiate.
Mhm.
And just as you have multiple teams in an organization that interact together, we have multiple fleets in an ecosystem. So 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 that's the analogy. So when you think of a big company, you have people in teams in organizations. We in an agentic firm or where agents participate in a company, what you have is agents, you have fleets of agents, and you have an ecosystem of agents. Now, if you think about what an organization does, a big company has thousands, tens of thousands of employees, and each of those employees have particular roles and they have particular skill sets to do those. We believe that the capability to do the same thing that that person was doing is now possible with an agent. Okay, so that obviously has some big ramifications, but for the purpose of what we're talking about, if you believe that to be true, and we do, what that means is there will be minimally in a company of thousands, you may have thousands of agents. Now, what
Mm.
we're finding though is today at least is a person has many skill sets and an individual agent cannot possibly match all of those skill sets. So what we find is you can replace or augment parts of what a person does in an organization, but not all of them. So for example, I may have a bank account open process. And if you think about what that really means is there's a happy path, the path that works, but when things don't work, there's exceptions that need to take place. Um, that's where people excel, and that's where agents are still learning. So if we actually wanted to replace an individual or augment an individual, we probably need multiple agents to actually do that based on where we are today with the capabilities of the LLMs, the brains, if you will, of the agents. So what we actually find is agents will today accompany or augment people, and maybe in the future they will replace the people. Let me give you another example. We're working with some executives in the asset management space, large scale infrastructure management. And one of the things that we have seen and what they've told us is that if you want to run a very large infrastructure project, the financial aspects of it, there's a lot of people that actually participate in that. And if you actually want to provide agents to augment that capability, you can do that for certain pieces of it, but not for all of it. But that doesn't change the fact that you can now have an organization that does the same work with fewer people and more agents, but it's not a one-to-one mapping. So, the analogy does break down a little bit, but the way we actually see it is where you have a person in an organization, you'd have one or more agents that fulfill or augment that type of role. That's why we actually believe that Andy Jassy, maybe it's not a billion, it may be a billion in 10 years, who knows? But in the near term, we still see agents proliferating in the enterprise. And I think it's incumbent upon us as leaders in the industry to figure out how do we actually do that in a compassionate, empathetic, and still effective manner. So I think there's still some work to be done in that area, but we definitely see that future coming.
Okay, I think you have really cleared my concept, and I thank for that. And let me uh, put it in front of you again, what you just mentioned, just for my audience. So what we are saying is that which is my confusion was because when I did R&D, I came to know there are around 14, 15 type of agents like execution agent, architect agent, planner agent, XYZ. There are many 14, 15 type of agents. So you are right. Now this makes sense that if Mustafa is a solution architect, in my JD, there might be 15 things I need to do. So when we create an agent, so there will not be an agent of a solution architect. For each line item might be there one agent. So every single task which I am doing, correct me if I'm wrong, every single task I am doing, maybe for that task an agent comes. And maybe one person when a agent, fleet of agent comes, so you give me an agent. So maybe for solution architect, for my role, my job, you end up giving me 20 agents, which will do different of my stuff. What do you think?
Yeah. Absolutely. So that is exactly what we see.
Ah,
So let me so I know there's a lot of literature and there's definitely some debate around how many types of agents that we
yeah.
have. But let me give you the three types that we see all the time, and they're higher level. So the very first one, the one that everybody probably thinks about is what we call a task-oriented agent. This is an agent that has a specific task that they need to do. They come up with a task plan, they farm that out perhaps to other agents or tools, and then they complete the task and they're done. And that's the most obvious and simple one. What we also see, though, is as you think about how agents collaborate, We actually see goal-oriented agents that work together towards a goal. And they use what we call super contexts or shared workspaces, kind of like Slack for agents, and they actually interact to fulfill a goal. So you could have one, two, three, 10, 100 agents actually collaborate dynamically to fulfill a goal. Very, very powerful. It is the ability to scale individual agents into agent fleets, then into agent ecosystems, and they all collaborate with shared memory. So that's the second type. And that power of that large amount of agents can actually tackle some very, very complex goals. So task-oriented agents, goal-oriented agents. The third type is what we call observer agents. And these are agents that listen to the environment. Okay. A stock ticker is the simplest example, I think. When a stock changes value, there's an event that occurs. An observer agent is listening to that. And maybe there's some news related to that stock. Maybe another NVIDIA headline came out or whatever. So we may have an agent listening for information about NVIDIA. That agent listens to those things, listens to those events, gathers those events, looks at perhaps a time series of those events, and then makes an intelligent decision and fires off another event, which may go to another observer agent or perhaps to information into a goal-oriented agent, or even something that kicks off a task-oriented agent to actually do something. So those are the three major types. When you get lower down, you can have like a judge agent and you can have an executor agent. We find those to be those are very low level primitives that aren't necessarily useful when you actually move to agents at scale. So we think of agents in those three dimensions: observer agents, task-oriented agents, goal-oriented agents. And with those, you can assemble literally any workflow, any process that you actually want. Again, the key aspect here is I can inject information into the agentic ecosystem through observer agents. Once it's in the agentic ecosystem, I can have a task-oriented agent get that information and execute tasks. Maybe when the NVIDIA stock ticker goes to a level, I may have the agent actually buy NVIDIA stock, for example. This is a trivialized example. So I'm sure somebody may be doing this. We're not involved in that quite yet. Um, or when that event comes in, that may contribute to the goal of maybe a portfolio management agent that wants to maximize the value of a portfolio. So that's a goal-oriented agent. Those three constructs of agents can actually build any type of workflow. So we stay away from those low-level primitives. I think you think about those like, chain of thought and all those kind of things. If you're deep in the bowels of a single agent, we believe, first off, I welcome those people, because the rising tide lifts all boats. Anybody that talks about agents benefits all of us, in my mind. But we focus on a higher level of abstraction for our clients because that's the way they think. Now, the interesting thing about it is a lot of the clients even think at a higher level. They think of the vertical industry, the business that they're in. So if I were to talk to a client about chain of thought, their eyes would glaze over. But if I say I have an observer that listens to stock ticks or something like that, and then I have a task oriented that may buy something, and I may have a goal oriented that maximizes the investment potential of a portfolio, all of a sudden you're turning it into a business context. You're turning it into an industry context. So what we actually find is those primitives are the best way to actually assemble business or industry specific agent ecosystems. And that's where we think the real opportunity is.
So let's bring this discussion to a little bit higher level on data products, right?
Sure.
Because we all know that last few decades we were working on centralized approach where we had this big enterprise data warehousing, blah blah blah. Now people start moving. Then this mesh came in, which is decentralized. I will also ask you your experience on mesh because in my point of view, in my circle, not a lot of people end up implementing data mesh in a bigger organization.
Hmm.
The people feedback given to me, small and SME level organization can adopt mesh because It has very strict rules, XYZ. We won't go into detail. But the thing is now I feel initially we were decentralized, like we were villages. Then we come towards a centralized, we become New York. Now we are going into federated approach where we are going to have colonies and housing societies within which we can have a small houses as well as buildings, right? So now we are going towards, for me, we are going towards federated approach where we are going to have small data products. When we say small data product, each business requirement may have end up having its own data product. Now there's a separate discussion, data product or data as a product. It goes into mesh and blah blah. Now, if we are going to create a data product, now within a data product has a complete life cycle. You have an integration layer, then you have data landing layer and staging layer, you have data preparation layer, you have semantic layer, you have BI, and you have notification. But this is whole cycle. Now it's debatable which layers are required. In data vault, you might not have so many layers, but if you end up creating dimensional model, you have many layers. So that's a debatable thing. Now, when we start creating it, now that is where human comes and implement it. Right? There is a business analyst, there is an architect, there is a tester, there is a developer. All these roles are there. Right? Now, initially, I was thinking that when I end up creating a requirement comes from data product, I categorize initially task, a goal, maybe task or observer. But further, when I think about it, it feel every role will have these three categories. I'm an architect. I need three kind of agents. I want to give one agent my goal, the other agent as a task, and the third category is observer. So how you categorize this category versus role?
Sure.
I hope I'm able to
Um,
ask my question.
yeah. So first off, I actually have implemented data mesh at a few companies.
Oh, okay.
And I have implemented many data products through my experience. But so I think people get confused around what data mesh actually is. Data, in my mind, I've written a book about it, so I have an opinion. People may differ, but data mesh is a way of looking at how you federate what is traditionally a centralized capability. And my belief strongly is that in this may be a little bit controversial or contrary to where a lot of people think. There's a strong impetus in organizations to centralize stuff, and historically that was done because they're scarce skills, and you had to put them in one location and leverage them as much as you can.
Yeah.
Historically been a cost focus on IT.
Yeah.
Um, but what we found is if you optimize for cost control, you will land on a centralized IT environment, and you may not get the benefits of federated capability. Nevertheless, um, what we find is that's the part that everybody focuses on in data mesh. The real opportunity, though, is data products.
True.
And the data products provide a bunch of different things, but simplistically, I'll trivialize it. It has a border. We know what's in it. It has an owner, so we know who makes the decisions about it. And if we delegate decisions to the owner of the data product, we get federated governance. Okay? And if we allow the owner to actually serve their customers, you get self-serve capability also. Those are kind of data mesh principles. What we find is whether they're centralized or federated or completely distributed, the key is you've delegated decision making to the group and organization that actually knows the most about the data product. So the myth about data mesh is that you had to have a federated organization or literally federated data marts and databases and data warehouses. I think people miss the point. Okay. The key point about data mesh is I have federated data products that may work in a centralized environment, if you will, but it's federated responsibility and accountability and ownership. And once you have that, you get federated governance. An owner can define a boundary. An owner is empowered to make decisions about that data product and govern its future. That's the piece that people forget. I would argue that If you look at all operational systems today, they are pretty darn close to what a data product actually means. They have an owner, they have a clear boundary, and the data in it's well understood. It's typically self-serve, maybe it's transactional, it has a user interface, and that owner is responsible for governance. What we've not done well is in the analytics space, adopt that delegation of authority and capability. So what we end up having is centralized, not necessarily the ideal level of accountability or responsibility. And what ends up happening is we get things happening very, very slowly. And data mesh is advocating the fact that we want to actually have delegated authority in the analytics space, just like we do in the operational space. Now, I'm going to answer your go.
Let me throw one question. I would love to have a separate podcast with you on dedicated on data mesh because I'm
Sure.
also an architect. In my recent company, I moved my company centralized into federated, but I did not go into MASH because wherever I go and talk to MASH, MASH mostly talk about decentralization. But you are the first one who is saying federated. So I'm very excited to talk about you that how you are saying data mesh as federated.
Sure. Okay. I'll give you a
Maybe
very
we
simple
have a
example.
dedicated session on it, you know?
Yeah, well, I'll just I'll
Yeah,
elaborate just a little bit here.
yeah,
We work with lots of clients who have massive data warehouses, data lakes, Delta, all that kind of stuff.
yeah.
Okay. And at first blush, if you misunderstood data mesh, you would look at it and go, I can't, that's not federated. That's completely centralized. I can't do anything. Wrong. Okay. That's completely the wrong answer. Okay. In fact, the moment you carve out a data product, which is a logical exercise in some cases. Once
Mhm.
I've identified an owner, and I said, these tables are the responsibility of that owner. And that person has customers and they're responsible for serving them, self-serve, hopefully. And that person is responsible for the governance. Is it PII? Is it HIPAA? Is it, GDPR compliant or what have you? As soon as you start to delegate that authority and decision making, you have a data product. You can have multiple data products. And now here's the thing is you've moved decision making to the people who know that data. And if they know that data and they know their customers, they know the requirements and what the customers actually need. And if they have decision making authority, they can actually execute better, faster, cheaper than any centralized model. You
So,
can still do data products and data mesh in a large scale environment. It's about delegating decision making and allowing them to actually carve out their boundaries and serve their customers. That's what it's all about. And that's why people get very, very confused about what data mesh actually is.
so,
Data mesh is a concept around how I can federate and delegate authority. And if I do that, I can get many, many benefits outlined in Zhamak Dehghani's principles. That's the key concept that people are missing. Okay. And if you're implementing data products, even in a centralized world, centralized IT technology environment, if you delegate the authority around that data to an owner, you get magical things happening. So that's the key about data products. I want to kind of talk a little bit about where we see a huge opportunity. Um, the concept that we are advocating, there's two of them, but the first one is what we call smart data products. So smart data products effectively are agents that accompany the data product and the data that allow you to do magical things with it. So the simplest thing is maybe I can now interact with a data product using natural language. Maybe I can actually use an agent to facilitate some of the transformations that actually take place inside the data product. Maybe I can use an agent to actually recognize when there's an alert or an exception in the data and do something about it. So what we actually think is the future is smart data products. It could be a very simple smart one where you have LLMs in there and you can then provide natural language and that kind of stuff. You can augment that with RAG type capability. But what we actually think is the real opportunity is when you augment data products with agents that can actually do things when things actually happen. That's where we actually see the future. So we call it smart data products. And we also believe there's a role around agent-enabled data engineering, which is a very different topic. But that's the capability that we actually see as the future for data mesh and data products is smart data mesh and smart data products.
So how do you recommend? Because we all, these new reports comes in. MIT says generative AI 95% project fails, and Gartner says by 2027 agentic AI 40% is going to fail, right? So these
Well,
reports are all out.
but they're right. There's been lots of qualms about that 95%. I read that in detail, and there's lots of podcasts that debunk that. But here's what I would say is while that 95% is absolutely wrong, the sentiments in it are still correct. And I think I would point more to a Stanford study. There's a few Stanford studies. Eric Broda, I can't remember his last name. It starts with a B. But anyway, long story short is there are real projects that are failing just like there's real data projects that are failing. So there's nothing new there. But here's what we actually see as the root cause. And this is, I think, is most important. Everybody that we see, clients that come to us, they say kind of a version of the same thing three different ways. They say, I'm building science experiments and I can't get them out of the lab and into production. Or they say, I'm in proof of concept purgatory. Okay, I can't stop these proof of concepts. None of them move into production. Or I'm dying the death of 1,000 proof of concepts. Here's the root cause of almost all of that stuff. Okay, I mean, there's a bunch of them, but the fundamental one is people don't understand that to deliver an outcome, you need to actually get something into production. Okay. If you want to deliver an outcome and get something into production, you have to think about it as enterprise grade. You have to think, you know this as an architect. You
Yes.
need to think about security. You need to think about, managing my data. You need to think about, is this thing discoverable, observable, operable? Is it trusted? Okay. Will it fit into my enterprise operations ecosystem? Will it emit alerts that can get consumed by an operations console so my support team can actually see what's happening? Here's the thing is although I welcome all the work that these agent toolkits do, Crew AI, LangChain, we've worked with them all, by the way. Again, the rising tide lifts all boats, including ours. But here's the thing, is if you're building stuff in using simple technology to deliver simple solutions, which today is my typical agents are two things. One is they're in a single Python file. Yes, maybe I import some stuff, but then you run it and it runs in a simple operating system process on your laptop. As a solution architect, as an enterprise architect, we look at those and go, that's not
That's
what's
not
going to get
reality.
production. That's not going to get anywhere. You
Yes.
have a science experiment. It's interesting, and as long as you recognize that the opportunity is to learn about the capabilities, nothing wrong with that. By the way, experimentation is the essence of learning. But don't mistake experimentation with getting stuff into production. So, number one that we see is the people who are building these agents, probably mostly data scientists, well, very smart geniuses in many cases, but they don't understand enterprise requirements. They don't understand what it means to be enterprise grade. So that is what we see as one of the major obstacles. By the way, if you're building an agent, I assume you already have a business outcome you want to get to. If you haven't got that, you're first off, you're not even near where you need to be.
Yeah.
But assuming you've overcome the business obstacles and you know what you need to do, number one, number two, number three, it's all about enterprise grade capability. If you haven't got it, you are not going to get into production. If you're not in production, you're not going to deliver an outcome. You're not going to deliver the value that the executives who are paying your bills are expecting. That is the number one issue that we actually see. So do projects fail? Absolutely. You know why? Because people haven't done the forethought. They haven't thought about enterprise architecture 101. They have not thought about the basic building blocks that are required to build an important, mission critical, perhaps enterprise grade application. So what we do is we have a very different architecture. I'll give you an example of what how we have overcome this. We
No, no, hold
started
on.
off,
Hold on. I
yeah,
want to bring one more angle into it.
yeah, sure. Go for it.
Unintentionally, without knowingly or unknowingly, actually you are supporting one of my innovation. I really want to bring that up now. And I want to say Joan is one of my data folk. I'm just telling him in Spain, I think sitting in Spain. I did a podcast on it. So I've done a three. I have my own data architecture, data and AI architecture. I have my own 4 by 4 formula, and I have my PVP approach. Maybe I can share the white paper with you. So PVP approach says productionizable viable product. I
Hmm.
innovated this 1.5 year back, 1 year back, and this is exactly what I said couple of days back into this. And if Adam, if you are listening this, I presented this and I've said the biggest challenge for agentic AI is what? The first thing what we see from our engineering team or AI team is, hey, my thing is working in dev and UAT is not working in production. And that is where exactly my PVP approach comes, where I say all new data and AI initiatives, new, fresh, has to be in production. When I say production, I'm not saying you don't need to do the development. I'm saying you have to sit into the production network zone. You have to do your R&D over there, maybe development, UAT, go to production. Why? You are absolutely replicating what I said actually the other day. The biggest issue is you never take care of PII data. Privacy, you never take care in development. Security, you hardly take care. When you talk about cores and processing power, you don't care. The libraries you use, open libraries, open source, you don't care whether they are production ready or not. So I also personally think these are the biggest issues because everything is working fine in development. The moment you go into production network zone, all crashes, right? And
Well,
I've
yeah.
yeah.
My proposition is you're not even, if you have a good and competent security, operations, and architecture and engineering capability, you'll never get into production because they will look at it and go, that's
That's
not
what happening
ready.
actually.
Yeah.
Actually, I have seen that they I have seen one of the project which started with I can't name exact number, but it started with 1 million budgeted. The moment they say it will be 1 million, they went into production. The moment they deployed in production, the cost become 165 million. Can you believe that?
That's incredible.
Yeah, that's incredible. 100 and
Hard to believe, actually.
yeah. So it failed, right? Become a white elephant. So you're absolutely right. Thanks for seconding my approach. I love it what you're saying, and that is one of the biggest challenge. Let me throw one more question before you go into the your solution. Which kind of use cases one should take? Because there is unstructured piece and there is structured piece. People are trying to pull data from structured table, throw into LLM. And we all know that LLM can only digest unstructured data, which is text. So how do you tackle these things? I feel one should, if you are looking into generative AI agents underneath agentic AI, I think to start with should start with unstructured use cases like documentation, like HR process, like yeah, all these kind of stuff. Yeah.
Well, I think so. So I think if you're looking at a particular solution, I think you need to use the right tool or tools for that solution. Most solutions that we've seen, unless you're building a chatbot, which is there's it's a well-established practice today. If that's all you're building, then yeah, you're just interacting using unstructured data. What we
Hmm.
find with just about any business process out there, whether it's HR or whether it's, financial planning, general ledger, whether it's insurance claims, or whether it's bank account open in financial services, every one of those needs multiple things. So let me give you a simple example. Bank account open. Uh, everybody knows, everybody's probably opened up a bank account before, but simplistically, you need to do a few things. One is, and I just give you the simplest example, you need to actually provide your name, and then they will look at that. That's structured data. And then they're going to go to, the credit agencies in North America, it's LexisNexis, and they say, "Hey, is Eric a real person? What's his credit rating, et cetera, et cetera." And then the second thing they probably do is they say, "I need proof of identity. Can you show me a driver's license?" And they take a picture of that. That's unstructured. It's an image. Okay.
Mhm.
And then there's a bunch of different OCR image recognition capability. And they actually scan that and say, okay, this is a real person. We have his driver's light. We can extract his driver's license number, and we're going to put that in the database as proof of identity or his passport number, whatever the case may be. Now you have structured and unstructured information in the same workflow. Agents can process both of those. So it's not a one size fits all. In fact, almost every single business process that we've seen of any materiality has unstructured stuff, whether it's in IT, whether it's a Jira ticket or whether it's a GitHub PR or a commit or something like that, or it's a Confluence document or it's something on SharePoint, a PowerPoint. That's unstructured data that goes into a process. I'm just giving you an example of an IT process, but there's also a lot of information that needs to be structured in there. You combine all of those together to fulfill an end-to-end business process. Whether it's IT process or a bank account open example that I have, the recognition is you have both of those, unstructured, could be images, could be text, could be voice, could be audio, it could be video. All those we see with our clients, but you also have to access databases, structured databases. Now, what we're actually seeing is if you start to think about how you're going to do this well, that unstructured data leads you to vector databases, okay, and RAG type solutions. And if you think about how to augment those, you may get into knowledge graphs or graph databases.
Yeah.
There's a continuum of opportunity that we actually see out there when you bring the right tools to address the right problem. So it's not a one size fits all. In fact, we see that all the solutions that we end up building have both. Some of them have raw interviews that we, transcribe and capture that gets filtered in. We access databases, whether they're in Postgres, Snowflake, or even the mainframe. That's all structured data, but it all combines. And what we do is we use the power of the LLM in the agent to do task planning, for example. We use the power of the LLM to ingest that unstructured data and make sense of it. But all that's part of the agentic process that we actually see every single day.
Okay, can I throw a more technical question here? Because I've done few podcasts and I've heard from another podcast from Francesco Papini as well, where he took a lot of European people online, and everybody says, maybe after this session, I will share that podcast URL with you. And everybody says when you throw structured data, and that's my personal experience as well, when we throw structured data into LLM, it doesn't work because of hallucination, because of no proper taxonomies and ontologies. So because if you throw banking data into LLM is trained on a generic taxonomies and ontologies, generic data, but banking data has a domain. So yes, if you throw, secondly, when you pull data from structure into text, which is LLM, structured data do not have relationships. It does not have a lot of things which unstructured data has. So I really want to understand when you say agents can pull from not pull. Agent can work on structure and unstructured. Unstructured, I know you pull and put into LLM. Are you saying you are pull from structure and throw into LLM? It's working?
Yeah, first off, I think whoever gave you that insight, I think they're wrong.
Okay.
They're categorically wrong. Let me explain why.
Yeah.
So let's talk about unstructured data. The very first thing you try and do when you bring in unstructured data is you try and gather meaning from it. You're trying to put structure to unstructured data. The whole purpose of the LLM is to translate unstructured, unknown data into structured, known data. And once it's structured and known, I can then use MCP to execute tools to access the environment. The whole point of the LLM is to translate unstructured data into something that is structured so it can be processed.
Actually, you're
That's the whole
absolutely right.
point.
No, you are going into the right direction. You are saying we convert unstructured into structure and then join with another structure. Is that you're saying?
Yeah, so I'll give you an example.
Yeah.
Almost all the stuff that we do, okay, takes unstructured data and puts it into a JSON structure. And by the way, the LLM's very good with that, good doing that.
Yeah,
And if you
fantastic.
give it a JSON schema, which it must adhere to, Most of the LLMs that we deal with today are very, very good, and they can actually take, for example, the fields. The good thing about the LLM is it can look at a driver's license, it could look at an invoice, and it can actually parse the information in there. And if you tell it what to look for, it will find that stuff independent of how it may be positioned on the image or in the text stream or what have you. But it's very good at finding the information, even if it's not in a very structured or it's a hard to understand format. It finds the structure, if you will. And if you tell it to put it into a JSON message following this JSON schema, all of a sudden what you've done is you translated an unstructured piece of information into something that's structured that you can actually work with. So here's the thing is agents are actually very good at dealing with structured information. But if you have structured information, the question you have to ask yourself is why would I use a non-deterministic machine, LLM, to process structured data in a deterministic fashion? We don't suggest that at all.
Absolutely.
In
Then we
fact,
are
what we
right.
suggest is you use the LLM for what it's really good at, which is getting unstructured data into some semblance of structure. And then what you do is once you have it in that structure, you use a deterministic engine. It's called a programming language. It's called
Yeah.
Python, for
Yeah.
example. Process it. So this is the fundamental architecture issue that we see with just about everybody that's doing agents or working with LLMs today is the typical scenario. Everybody thinks about a chatbot as the example. But now chatbots and Claude, for example, you can actually add multiple tools into that chatbot that it can access. The interesting thing about that is it works really, really well when you have three, four tools. Okay. But in any enterprise, you will have hundreds, if not thousands of tools. The API to access the banking system is a tool. The
Yeah.
API to access LexisNexis is a tool. The API to do a payment is a tool. Okay. So when you have anything more today with the LLMs that we have, anytime you have more than three, well, anytime you have 5 to 7 tools or more, it does not understand how to work with those.
Yeah.
That's a fundamental flaw. Okay.
You're absolutely right.
So as we ask the LLMs to do more, which is inevitable, as they get more powerful, we ask it to do more. We are running into the problem where we're asking too much of the LLMs. And that's the fundamental architecture problem that we see over and over again. MCP is fantastic until you have 7 or 8 tools and the LLM can't figure out what to do with it. That's the architecture problem that we see. We've addressed that. We have a different architecture. This
Okay.
now gets into my architecture question, but the fundamental underpinnings, when you look at what an LLM does to solve a complex prompt, okay, what it does it in a very black box fashion, but it comes up with a task plan. If you look at ChatGPT and you click on the thing when it says thinking, you
Yeah.
can actually see what it's thinking. Okay. But it's opaque and you can't guide it. Okay. But you can actually see it's coming up with a task plan. What you don't see necessarily is inside that task plan, it's calling a tool or it's accessing the
True.
internet and what have you. Okay. And when, by the way, once it's actually figured out the tools, then it has to actually call the tool. It has to plug in the parameters to the tool. Then it has to call the tool. It has to process the response, understand the response, and hand it off to the next tool. That's why this stuff doesn't work when you add 5 to 7 tools. It's too complex for the LLMs today. Will they one day get to it? Yes. One day they will be able to handle 10, 100 tools. But that, I can't wait for 2 years. My clients can't wait for the next, for GPT-6 to come out, not let alone GPT-5. So we can't wait for that. So what we've done is we've said, why don't we use the LLM in a fashion that is actually aligned with its capability? So we asked the LLM to do one thing. A prompt comes in. Well, actually, it's kind of a combination of 3 things. But we ask it to come up with a task plan in a very clear format. Our task plan is JSON that complies to a JSON schema. It does that perfectly 100% of the time, virtually 100% of the time. And then what we do is we ask the LM after it's come up with a task plan, look at the universe of agents, and we provide some hints and guidance to plug in which agent or tool can do the step in the task plan. Then we say, based on the prompt, plug in the information, okay? from the prompt, ascertain the parameters and plug them into the task plan for that particular agent that you put into that task step. Then we hand it off to a deterministic engine, Python, to execute the task plan. So now what we've decoupled is the task planning from the execution. Today's architecture has tightly coupled planning and execution, and it fails almost all the time in a complex scenario. Ours, the task planning is the equivalent of asking Cursor to write a 100-line program. To give you an if anybody who's used the coding tools today, whether ChatGPT and cut and paste if you want, or Cursor or Windsurf or any of the other ones, if you ask it to do the equivalent of a 100-line fast API service, it does that flawlessly. Yes, it's non-deterministic, but every time I've done it, it works 100% of the time correctly. It actually runs out of the box. Cut and paste, whatever, it runs. If I ask it to do the equivalent of a 1,000-line program, some of the LMs are pretty good. They can do it most of the time. If I ask it to do the equivalent of a 10,000-line program, every one of them fails. Every single one, and you get this, this 10,000-line hunk of code, and you can't figure out what it did, how it does it, you can't debug it, and you can't re-architect, you might as well throw it away. That is the experience that just about everybody has. What we want to create that task plan is the equivalent of asking an LLM to create a 100-line program. It works flawlessly 100% of the time. Yes, it's non-deterministic, so I'm sure one time it's not going to work. But once we have the task plan, we've plugged in the prompts, we plugged in the agents or the tools that execute that. Then we hand it off to a deterministic engine, Python, to execute it. That Python program will go to the first step in the task and it says, oh, that one's for another agent. We fire it off to another agent. That agent does exactly the same thing, gets the sub prompt, okay, the smaller section of the prompt for that particular step, and does exactly the same thing. Comes with a task plan, fills it in, and executes it. What ends up happening now is we've done the equivalent of architecture 101, which is I've broken a monolith into its smaller parts and I execute the smaller parts. And we happen to do it recursively, so until finally the agent actually executes tools. Once you execute the tool, it's more or less of a kind of an atomic action. Something actually happens. The agents become more or less a coordination mechanism. All of a sudden, what we get is the best of both worlds. It works flawlessly. It does not suffer the problems that everybody else seems to have. So we believe the current trajectory in the architecture that folks are actually going is broken. And we think we can actually prove that fact. And we have a different architecture that we think is where people are starting to move to, but we think we're ahead of the game right now.
I think, first of all, we have a time check of 8 minutes. And the session is going very good. Actually, you really has solved my a lot of problems, clear a lot of doubts. And you are absolutely right that agentic AI is not about only generative AI. Because currently people think we will in every agent will be a Gen AI LLM agent. I also say it's not like that. Agents will run for unstructured piece. Actually, you are again the first person, actually second person after 𝘊𝘢𝘯𝘢𝘥𝘢, because 𝘊𝘢𝘯𝘢𝘢 is also building a tool called text analytics. So you give unstructured data to text analytics and it will convert into a structured format. When you say structure into JSON format or any CSV format, right?
So this Bill is using Gen AI in a way that is the exemplar of what it's supposed to do.
Yeah.
Unstructured to structured data. There you go.
Yeah. So actually he doesn't use LLM. He has its own proprietary engine. And behind it, it's something like same thing, right? And convert. So you are right that agents for unstructured piece should use generative AI, but not for structured piece. For structured piece, there are deterministic other technologies there. So agent will work relevant tools and end of the day, bringing everything into semi-structure or a structured format, which can be actually JSON is a kind of structure. It's a semi-structured kind of structure. Once it is in JSON format, you can very well connect with the structured data, and then you can get the thing out. I think this is a very good session, and we have covered this, and that is what I was also telling into the deck which I presented that we have to work. But that is where I was a little bit confused that how structured data will work in Gen AI. So you are also saying we don't need to throw structured data into Gen AI. LLM is not meant for that. LLM is for unstructured data.
Yeah. Well, that's my belief and my practice.
No,
The
absolutely.
question you got to ask yourself is, if I have structured data, why do I want to? There has to be a really good reason to to hand it off to a non-deterministic engine. Sometimes there is, by the way. So I'll give you a simple example where it does make sense. Is I have events in my observer agents. I have a bunch of structured events coming in. The NVIDIA stock ticker, some news, maybe that's a little bit unstructured, but there's some structure to it. All that comes in, and what the LLM does is, in our case, the observer agent with its LLM, it takes into account all of those different formats of structured information and then renders a decision about it. So the LLM is more than just generating or interpreting unstructured data. It can actually make decisions based off of structured data. In fact, if you give it structured data and you tell it the structure of the data, it can
Yeah,
actually make
give
very,
matter.
very good decisions. So it's not a black and white scenario, but in the example that you mentioned, many people are using the LLMs perhaps incorrectly. But they can actually use structured data very, very well. You just have to think through what your problem, what the requirements of your problem actually are.
No, I also believe that you can do it, as you mentioned, if you have a proper metadata of the structured data. If you
Yes.
have tables coming in, you have proper metadata, you have defined the columns, you have defined the relationship of tables, columns, all those things that are there, then it makes sense. But when people try to do it, I think they overran the ROI. Because when you throw structured data into LLM, tokens cost come into picture. Actually, in my scenario, people throw GL data into it. So,
Yeah. Well, it's kind of funny because we don't actually run into that problem because our approach is token light. In fact, and in the LLM we use, we actually use an LLM. We are experimenting using 4B LLMs, not the big huge reasoning ones. We actually have demonstrated that we can do what we want to do with a 4B model. Okay, not a 40, 75, or 500B model, a 4B model. Super low cost, super low token counts, all based off of this new architecture that we have, while still being able to deliver the broader observer agents, the task-oriented agents, and allow agents, tens, thousands, hundreds, thousands of agents to actually collaborate, because we have an architecture that actually facilitates that. So anyway, I've been pitching far too much about our vision, but my apologies for that. Hopefully, the principles though are good for your audience.
no, this is great. Actually, you really decoded this whole agentic AI solutioning. I think I'm very much open to do a demo on your product as well. We can do that in
Sure.
the future as well. We can plan that.
Yeah, we actually, so one last thing I'll mention. So we have been working with many clients, some of which are on my LinkedIn, some of which are under NDA, so I can't talk too much about it. But we have actually harvested our learnings, and everything that I've talked about. We actually have a product that we hope to open source in the new year, give or take. But we have a product that actually does all this stuff. We have demos that show the equivalent of a bank account open with 7 agents talking to 4 core services, talking to 7 different tools, and they all facilitate a bank account open process. We have an example where we have goal-oriented agents. We have 7 or 8 agents that all collaborate and talk to each other, and you can actually see in real time what they're saying to each other. So we have multiple demos like that. And everything runs, by the way, and everything's a microservice, everything's a container, and everything runs on Kubernetes. So it's all enterprise grade. But I would very much welcome doing a demo at some
Now
point.
we can do that. As I mentioned that I have an audience from 30 plus countries, all Europe, US, Australia, Canada, all those. Other than Africa, I haven't covered Africa yet. But other than that, I have reached at 30 plus countries. So I will drop you an email,
Okay,
and I can see your corporate email as well. And we can plan a demo in a quarter or time. So again,
excellent.
Eric, it was a great pleasure to talk to you. I think we have to plan two. One is on data mesh because
Sure, I would be happy to do that.
now I can bring couple more industry leaders who has worked on data mesh or who want to work on data mesh. Actually, as I mentioned, I have, after evaluating data mesh, I went towards federated because what I thought data mesh is too strict for a big organization. But when you use the word of federated for data mesh, that triggers me that, hey, nobody else talked about federated approach in data mesh. Everybody talked about decentralized, right? And in data mesh, every product must talk to another product XYZ, but we can have a separate session. I can bring
Sure.
two, three
Absolutely.
leaders and we can talk on that.
Excellent. Okay, I think we're at time. So let me just say thank you very much, Mustafa, for having me on the show. And I look forward to maybe being on it again.
But yeah. And normally what I do, I book my guest bare minimum next year, same week, same month, if you don't mind.
No, that's fantastic. I'd love to do that. It's
So
a
at
long
least,
time from now, but so I'm pretty sure I could open my calendar up to
yeah, yeah, yeah.
accommodate.
So I'll book you next year, and in the middle, we plan this other demos and other stuff if you can. Yeah,
Excellent. Okay,
awesome.
Mustafa,
Thank you.
thank you very much, sir.
Nice, Jay. Take care. Bye bye.
Bye now.